And our planet, Earth, is a dynamic and ever-changing world. Deep beneath our feet, immense forces are constantly at work. These forces shape our lands, our oceans, and indeed our very existence. Among the most dramatic and awe-inspiring manifestations of this inner power are volcanoes. They are windows into the Earth's molten heart, capable of breathtaking creation and fearsome destruction. These majestic mountains can lie dormant for centuries, seemingly peaceful, only to awaken with a sudden fiery roar, reminding us of the raw, untamed energy that simmers just below the surface we inhabit. Their unpredictability is a constant source of wonder, and at times apprehension for those who live in their mighty shadows. Volcanoes are not merely mountains that spew fire, they are complex geological structures. They are vents, or openings, in the Earth's crust through which molten rock, known as magma, along with hot gases and ash, can escape from deep within the planet. When this magma reaches the surface, it is called lava. The sight of glowing lava flowing down a mountainside is a truly spectacular, yet humbling, experience. It is a vivid reminder of the planet's formative processes, the very same processes that have shaped continents and created islands over millions of years. Each eruption, big or small, tells a story of geological time and planetary evolution. The sheer power unleashed during a volcanic eruption is almost beyond comprehension. Rivers of molten rock can reshape landscapes in mere hours, and columns of ash can rise many kilometers into the atmosphere, affecting weather patterns across vast regions. The sounds, the sights, the trembling earth all contribute to an overwhelming sensory experience. Yet despite their destructive potential, volcanoes are also creators. They have given us fertile soils, precious minerals, and even the very air we breathe through gases released over geological eons. Understanding these fiery giants is crucial not just for safety, but for appreciating the intricate workings of our world. Throughout history, human civilizations have had a complex relationship with volcanoes. They have been worshipped as gods, feared as demons, and studied by scientists eager to unlock their secrets. From the ancient ruins of Pompeii, preserved by volcanic ash, to the modern-day monitoring stations that keep a vigilant eye on active peaks, our fascination and need to understand these natural wonders persist. As we delve into some of the recent volcanic activities, like the dramatic events at Kilauea, we continue to learn more about these magnificent and sometimes menacing features of our home planet, Earth. The Hawaiian Islands, jewels of the Pacific, are themselves born of volcanic activity. Among these, Kilauea is one of the world's most active volcanoes, a place of constant change and dramatic beauty. Recently, in late May 2025, Kilauea once again put on a spectacular fiery show. Around the 25th or 26th of May, this restless giant decided to awaken, sending fountains of glowing lava soaring high into the sky. These incandescent jets reportedly reached astonishing heights of up to 1,000 feet or 300 meters. To put this into perspective, that is comparable to the height of the famous Eiffel Tower in Paris, a truly remarkable display of nature's raw energy. This latest eruption occurred within a closed area of the Hawaii Volcanoes National Park. Thankfully, this specific location is situated about 200 miles southeast of Honolulu, the bustling capital. Due to this remote setting, the eruption posed no immediate threat to the lives or properties of nearby residents, allowing scientists and observers to witness the event with a degree of safety. The Hawaiian Volcano Observatory, as always, has been diligently monitoring Kilauea's every mood swing, providing crucial data and updates. Their work is essential in understanding the volcano's behavior and ensuring public safety when such events occur, helping people to live alongside such a powerful natural force. It is important to note that Kilauea's activity has been rather intermittent since an earlier eruption recorded on December 23, 2024. Since that time, it has shown a pattern of erupting periodically. Some of these eruptions have been brief, lasting only around 13 hours, while others have persisted for as long as 8 days. Indeed, some reports even suggest that Kilauea has been erupting on average about once a week since December of the previous year. This constant state of flux makes Kilauea a fascinating subject for volcanologists worldwide, offering continuous opportunities to study volcanic processes in real time. The dramatic lava fountains are a hallmark of Kilauea's eruptions, painting the night sky with brilliant hues of red and orange. This spectacle, while beautiful, is a potent reminder of the immense heat and pressure lurking beneath the Earth's crust. Each pulse of lava, each plume of gas, adds another chapter to the ongoing story of Kilauea's geological evolution. The Hawaiian people have a deep cultural connection to Pele, the goddess of volcanoes and fire, who is said to reside in Kilauea. For them, these eruptions are not just geological events, but powerful spiritual occurrences, a dialogue between the land and its ancient guardians. Far to the north, in the rugged, icy landscapes of Alaska, another volcanic giant has been stirring. Mount Spur, a formidable peak, has been showing signs of increased seismic activity, raising concerns among scientists and residents about the potential for an eruption. The Alaska Volcano Observatory, or AVO, has been keeping a very close watch on this situation. As of late May 2025, they reported a notable increase in earthquake activity beneath the volcano, with around 100 such seismic events being recorded each week. This is a significant number, indicating that something is changing deep within the mountain. The heightened monitoring of Mount Spur actually began much earlier, back in April 2024. This was due to an initial spike in seismic activity that caught the attention of the vigilant AVO team. By October 2024, these tremors had further intensified, increasing from about 30 events per week to a more alarming 125 per week. While there has been a gradual decline in the perceived likelihood of an immediate large-scale eruption since then, Mount Spur officially remains in an elevated state of unrest as of May 29, 2025. Low-level unrest continues, though thankfully no significant changes pointing to an imminent major eruption have been observed very recently. Gas measurements taken around May 23, 2025 provided further clues. Although these measurements showed slightly lower emissions compared to previous readings, they were still within the bounds of uncertainty. Crucially, these gas readings indicate the continued presence of magma beneath the volcano. Matt Haney, a scientist from the AVO, noted that a pause in ground deformation around the volcano suggests that the shallow intrusion of magma might have stalled for now. However, he also cautioned that the potential for an eruption certainly remains, and vigilance is key. The mountain is not yet settled. Mount Spur has a history of significant eruptions. Its last major event occurred in 1992, producing substantial ash clouds that drifted over Anchorage, Alaska's largest city, causing considerable disruption. Before that, a notable eruption with similar characteristics took place in 1953. If Mount Spur were to erupt powerfully again, it could generate ash plumes reaching astonishing altitudes of up to 50,000 feet. Such plumes would pose a serious hazard to aviation, potentially leading to airport closures and affecting air travel across the region. Furthermore, enormous mudslides and avalanches of volcanic debris, known as lahars, could travel at speeds of up to 200 miles per hour. Though thankfully no communities are situated in the immediate danger zone of such flows. The year 2025 has already proven to be a remarkably active one for volcanic events across our globe. It is not just Kilauea and the concerns around Mount Spur that are making headlines. Numerous other volcanoes have awakened, reminding us of the dynamic nature of our planet's geology. According to recent reports, over 50 volcanic eruptions have been recorded worldwide in the first 5 months of this year alone. This figure underscores the constant geological activity that is shaping and reshaping our world, often in the most dramatic and fiery fashion. It is a testament to the powerful forces at play beneath the Earth's surface. As of May 2, 2025, the tally of confirmed volcanic eruptions had reached 54. What is particularly interesting is that a dozen of these eruptions occurred in new locations, meaning volcanoes that had been dormant for some time decided to spring back to life. While the number might seem high, it is worth noting that typically scientists record between 50 to 70 volcanic eruptions globally each year. So while 2025 is certainly active, it is currently tracking within the expected range of global volcanic behavior. However, each eruption, regardless of its size, contributes to our understanding of these complex systems. These volcanic eruptions are not isolated events. They are intrinsically linked to another powerful geological phenomenon: earthquakes. The movement of magma beneath the Earth's surface, the shifting of tectonic plates, and the stresses released during eruptions all contribute significantly to seismic activity. Therefore, an increase in volcanic eruptions often correlates with an increase in earthquakes of various magnitudes, from minor tremors only detectable by sensitive instruments, to larger quakes that can be felt by populations living nearby. This interconnectedness highlights the complex and powerful geological engine that drives our planet. The sheer number of eruptions in 2025 serves as a global reminder of the Earth's restless nature. From the Pacific Ring of Fire to volcanic systems in Iceland and Italy, the planet is constantly venting its internal heat and pressure. Scientists around the world are working tirelessly using an array of sophisticated technologies to monitor these volcanoes. Their goal is not only to understand the fundamental science behind these events, but also to provide timely warnings and mitigate the risks to communities living in the shadow of these magnificent yet potentially hazardous natural wonders. This global vigilance is more important than ever. Section 5, Around the World, Notable Eruptions of 2025. Beyond the well-publicized activity at Kilauea and the watchful eyes on Mount Spur, several other volcanoes across the globe have made their presence felt in 2025. For instance, Mount Etna on the island of Sicily in Italy, one of Europe's most iconic and active volcanoes, erupted just a couple of days ago, around June 2nd, 2025. This grand old mountain, a frequent performer on the volcanic stage, once again spewed huge plumes of ash into the Mediterranean sky. A familiar sight for the resilient people of Sicily who have lived alongside Etna for millennia. Its activity is a constant reminder of the geological forces shaping southern Europe. Elsewhere, technology has provided us with unique views of these fiery events. On May 13, 2025, a thermal camera captured a dramatic volcanic eruption at an unspecified location in Asia. Such imagery is invaluable to scientists, allowing them to observe the thermal signatures of eruptions, understand heat flow, and monitor the spread of lava even in remote or inaccessible areas. Each piece of data, each image, helps to build a more complete picture of how these complex natural systems operate, contributing to better forecasting and hazard assessment for communities that might be at risk from such events. Indonesia, an archipelago nation renowned for its numerous active volcanoes, also witnessed significant activity earlier in the year. On April 3, 2025, an unspecified volcano in this vast island chain erupted quite powerfully. This eruption created a huge column of ash that billowed high into the atmosphere, a common yet always impressive sight during such events. Indonesian authorities are well versed in managing volcanic crises given their nation's geological setting, and their expertise is crucial in safeguarding the millions who live in close proximity to these fiery mountains, a constant dance between human life and volcanic power. The volcanic drama was not confined to warmer climes. Iceland, a land forged by fire and ice, experienced its own volcanic spectacle on April 1, 2025. An unspecified volcano there erupted, spewing forth both molten lava and dense clouds of smoke. Icelandic eruptions often capture global attention due to their potential to disrupt air travel with ash clouds, as famously occurred in 2010. Meanwhile, beneath the waves off the coast of Oregon in the United States, the axial seamount, an undersea volcano, is showing signs that it might erupt before the end of 2025. Instruments indicate its magma reservoir is refilling, causing the volcano to bulge upwards, a telltale sign of impending activity from the deep. Section 6, the Science Unveiled, Understanding Volcanic Eruptions. To truly appreciate the spectacle of a volcanic eruption, it helps to understand the immense geological forces that are at play deep within our Earth. The primary driver behind most volcanic activity is a concept known as plate tectonics. The Earth's outer shell, or lithosphere, is not a single solid piece. Instead, it is broken into several large and small rigid sections called tectonic plates. These plates are constantly, albeit very slowly, moving, drifting apart, colliding or sliding past each other. It is at the boundaries of these plates that much of the world's volcanic and earthquake activity is concentrated. Beneath these tectonic plates lies the mantle, a layer of hot, semi-molten rock. In certain conditions, particularly where plates are pulling apart or where one plate is forced beneath another, a process called subduction, this mantle rock can melt to form magma. Magma is less dense than the surrounding solid rock, so it tends to rise towards the surface. It often accumulates in underground chambers, known as magma chambers, beneath volcanoes. As more and more magma fills these chambers, the pressure begins to build, sometimes over many years or even centuries, like a giant underground pressure cooker reaching its limit. When the pressure from the accumulating magma becomes too great for the overlying rocks to contain, an eruption occurs. The magma, along with dissolved gases like water vapor, carbon dioxide and sulfur dioxide, forces its way upwards through weaknesses or conduits in the Earth's crust. Once it reaches the surface, as we know, this molten rock is called lava. The style of eruption can vary dramatically depending on factors such as the magma's composition, especially its viscosity or thickness, and the amount of trapped gas. Some eruptions are effusive with relatively gentle lava flows, while others are explosive, blasting ash and rock fragments high into the air. The type of magma plays a crucial role in determining how a volcano erupts. Magma that is thin and runny, like that often found in Hawaii, allows gases to escape easily. This typically results in less explosive eruptions with flowing lava, creating shield volcanoes like Kilauea. Conversely, magma that is thick and sticky traps gases, leading to a buildup of immense pressure. When this pressure is finally released, it can result in violent, explosive eruptions, forming steep-sided composite volcanoes like Mount Spur or Mount Vesuvius. Understanding these fundamental scientific principles is key to predicting volcanic behavior and mitigating the associated risks. Section 7. The Ring of Fire, a belt of intense power. When we look at a map of global volcanic and earthquake activity, one prominent feature immediately stands out: the Ring of Fire. This is not a literal ring of burning flames, but rather a vast, horseshoe-shaped zone that stretches for approximately 25,000 miles or 40,000 kilometers around the basin of the Pacific Ocean. It is, without doubt, the most geologically active region on our planet. This immense belt is home to an astonishing number of volcanoes, over 450, which accounts for roughly 75% or 3 out of every 4 active and dormant volcanoes on Earth. The Ring of Fire's path is extensive and truly global in its reach. It extends from the southern tip of South America, up along the western coast of the Americas, encompassing the Andes Mountains and the volcanic peaks of Central America and North America, including Mount Spur in Alaska. From there, it crosses the Bering Strait, sweeping through Japan, the Philippines, and Indonesia, all nations with a high density of active volcanoes. It then continues southwards towards New Zealand and even extends its influence to parts of Antarctica. This vast arc is a testament to the dynamic nature of the Pacific Ocean's edges. The intense volcanic and seismic activity within the Ring of Fire is a direct consequence of plate tectonics, the very process we discussed earlier. This region marks the boundaries of several major tectonic plates, including the massive Pacific Plate and smaller plates like the Nazca, Cocos, Philippine and Indo-Australian plates. Along these boundaries, plates are colliding, sliding past each other, and being subducted, one plate diving beneath another. These interactions create the perfect conditions for magma generation and the build-up of stress that leads to both volcanic eruptions and the vast majority of the world's earthquakes. Indeed, about 90% of all earthquakes occur within this zone. The significance of the Ring of Fire cannot be overstated. It is a crucial area for understanding how our planet works, how new land is formed, and how immense geological forces shape our environment. The numerous eruptions and earthquakes in this zone pose significant hazards to the millions of people who live along its path. However, these same volcanic processes also create incredibly fertile land for agriculture and valuable mineral deposits. Therefore, studying the Ring of Fire is essential not only for scientific knowledge, but also for developing strategies to live more safely and sustainably in these dynamic regions of our world. Section 8. The dual face of eruptions, creation and destruction. Volcanic eruptions, while undeniably powerful and often destructive, also possess a remarkable creative force. They are a fundamental part of Earth's natural cycle of renewal and transformation. When a volcano erupts, the immediate consequences can indeed be devastating for the local environment and any human settlements nearby. Rivers of molten lava, reaching temperatures of over 1,000 degrees Celsius, can engulf everything in their path, burying landscapes and altering coastlines. Ashfall can blanket vast areas, collapsing roofs, choking vegetation, and contaminating water supplies, impacting ecosystems for years. The environmental impacts can extend far beyond the immediate vicinity of the volcano. Large explosive eruptions can inject enormous quantities of ash and gases, particularly sulfur dioxide, high into the stratosphere. This sulfur dioxide reacts with water vapor to form tiny sulfate aerosol particles. These particles can reflect sunlight back into space, leading to a temporary cooling effect on the global climate, as was observed after the eruption of Mount Pinatubo in 1991. Volcanic ash clouds also pose a serious hazard to aviation, as the fine abrasive particles can damage jet engines, leading to widespread flight cancellations and disruptions to global travel. However, amidst this potential for destruction, there is also profound creation. Over geological timescales, volcanic activity is responsible for building mountains, creating new islands from the seafloor like the Hawaiian archipelago, and enriching soils. Volcanic ash, once weathered, breaks down to form incredibly fertile land. This is why, despite the risks, many agricultural communities around the world thrive in volcanic regions. The minerals released during eruptions replenish the soil, making it ideal for growing crops, supporting diverse ecosystems, and sustaining human populations for generations. It is a long-term gift from the Earth's fiery interior. Furthermore, the very act of destruction can pave the way for new life. Lava flows, once cooled and solidified, create fresh, barren landscapes. Over time, pioneer species of plants begin to colonize these new rocks, gradually breaking them down and creating the first traces of soil. This process of ecological succession eventually leads to the establishment of new, vibrant ecosystems. In this way, volcanic eruptions, while appearing catastrophic in the short term, are an essential part of the Earth's ability to regenerate and diversify its environments, a constant interplay of dismantling and rebuilding on a planetary scale. Section 9. Living beside giants, humanity's dance with volcanoes. Coexisting with volcanoes presents a unique set of challenges and opportunities for humanity. These magnificent geological structures command respect, for their power is immense and their behavior, while increasingly understood, can still be unpredictable. Millions of people worldwide choose to live in the shadow of active or dormant volcanoes, drawn by the fertile soils, the geothermal energy resources, or simply by the cultural and historical significance of these landscapes. This proximity necessitates a continuous effort to understand, monitor, and prepare for the possibility of future eruptions, a delicate dance between human settlement and nature's might. Modern science has made remarkable strides in volcano monitoring. Observatories like the Hawaiian Volcano Observatory and the Alaska Volcano Observatory employ a wide array of techniques to keep a vigilant watch. These include seismometers to detect earthquakes caused by moving magma, GPS instruments to measure ground deformation as magma chambers fill or empty, gas sensors to analyze the composition of volcanic gases, and thermal imaging to detect changes in heat flow. This constant stream of data allows scientists to assess the level of unrest at a volcano, and in many cases provide timely warnings to communities at risk, enabling evacuations and saving lives. Beyond the risks, volcanoes offer tangible benefits. Geothermal energy, harnessed from the Earth's internal heat in volcanic areas, provides a clean and sustainable power source for many communities. Volcanic landscapes, with their dramatic peaks, hot springs, and unique geological features, are also major tourist attractions, bringing economic benefits to local regions. The rich mineral deposits associated with volcanic activity have been exploited by humans for centuries. Thus, the relationship is not purely one of hazard. There is also a symbiotic aspect where human ingenuity finds ways to benefit from volcanic environments. Ultimately, living with volcanoes is about balance and respect. It requires acknowledging their power, investing in scientific understanding and preparedness, and making informed decisions about land use and development in volcanic regions. The fiery displays of Kilauea, the rumbles beneath Mount Spur, and the numerous other eruptions around the globe in 2025 are potent reminders that our planet is alive and ever-changing. By continuing to study these natural wonders, we not only protect ourselves, but also deepen our appreciation for the incredible forces that have shaped and continue to shape our world. It is a relationship that demands our constant attention and our deepest respect.